Ehi ehi ehi, good evening, buonasera, buonasera, benvenuti e bentornati qui nella live in cui facciamo LeetCode, in cui capiamo come riuscire a passare un'interview di Google. Iniziamo con un paio di video, circa una mezz'ora in totale. E poi continuiamo con i due LeetCodes rimasti per la parte di array, così da poterci concentrare poi in futuro sulle altre parti. Va bene? Scusate se mi vedete che ho mangiato da poco, quindi ho mangiato più che altro, ho dei biscottini. Ho bisogno di rinforzo psichico e morale, quindi ho bisogno di biscottini. Scusa Gianluca nutrizionista, ma oggi va così. Allora, bisognerà fare tanto, però noi ci proviamo, noi siamo qui. Cominciamo ad ascoltare cosa ha da dire il nostro caro Sami e la nostra cara Giuliana a riguardo come risolvere il Google Coding Interview Question. Da questo momento in poi parlerò in inglese perché mi devo abituare, quindi.
Recruiter here at Google. In this video, we'll show two software engineers at Google working through a mock technical interview question. Please note that this example is not a question you will be asked exactly. However, it represents the type of questions we like to ask our candidates. One that allows you to state your assumptions, improve your solution, and is ultimately open-ended enough to show us how you think. If you're interested in seeing an example of solving a systems design question, or learning more about our hiring process, visit the videos linked in the description below. On to the mock interview.
Hello, my name is Sami. I'm a research scientist at Google Research, and today I'll be playing the role of the candidate.
And I'm Juliana. I'm a software engineer at YouTube, and I'll be playing the role of the interviewer. Just as a reminder, you won't have access to a compiler or IDE during your interview, so practice writing code with Google Docs.
Try to do it at home, write code, make sure your code is tested. Do this process before you come to the interview.
And don't worry about small syntax errors like which substring to use for a given method. Just pick one, like start end or start length, and let your interviewer know. Okay, let's get started. Okay, so Sami, here's my technical question for you. A farmer wants to farm their land with the maximum area where good land is present. The land is represented as a matrix with ones and zeros, where ones mean good land and zeros mean bad land. The farmer only wants to farm in a square of good land with the maximum area. Please help the farmer to find a maximum area of the land they can farm in good land. I'll paste the question, and that includes an example as well for you.
Awesome. May I take a moment to read it and then ask you clarifications?
Of course.
Thank you. Awesome. So my first question, must it be a square, the area they want to farm, or could it be a rectangle?
For this problem, we only want it to be returning a square.
Awesome. Okay, thank you.
As a reminder, it's important to get clarity whenever possible. Many questions will be deliberately open-ended because we're looking to see how you engage with the problem and your primary method for solving it. Be sure to talk through your thought process and feel free to ask specific questions if you need clarification.
And I can think of like the naive solution, but probably I shouldn't do this, but I'll just run it by you.
Okay.
I can loop over every position. And for every position, I can basically start from that moment onwards, go left and right, and count however many ones I can find in like a rectangle or a square, sorry. But that would be, if let's say the dimensions of the square is like n by n, that would be at best n to the 4, which is not ideal. And I assume by posing this question, you want to find an efficient solution.
Yes.
This was a good example of explaining your thoughts. Remember, we want to understand how you think, so it's always good to explain your thought process and decision making throughout the interview. Not only evaluate your technical ability, but also how to solve your problems. Be sure to explicitly state and check your assumptions with the interviewer to ensure they are reasonable.
I'm wondering if you can just visualize what maybe this brute force approach would look like, maybe using the example.
Sure. Okay, so the brute force, if I want to visualize it, so I just pasted the example, and I'm going to go over every index, ij index, and I halted the first, this is the second, this is the third, etc. Let's say we get here in this iteration, so I is becoming, let's say, 2, and j is becoming 1 in this position, the row and column. So from this point, as every point that we go to, we start another double for loop, going to the right and bottom. So here I go one step to the right, there is a 1, so I continue. And then I go to the bottom, there is a 1, and I continue. And then I go to the right of it, there's a 1, I continue. I wonder if that makes sense. So first we start saying, okay, when we get to this point, we know that we can do a 1 by 1. Then we ask, can we do a 2 by 2? And if the answer, to answer that, we have to complete the 2 by 2 triangle, so we have to look in this vicinity, so to speak.
Yes.
Then we say, okay, now yes, I know I can do a 2 by 2 starting from this position. Can I do a 3 by 3? And to answer that, we have to go on this like wrapper. Like I'm gonna select them 1 by 1 because it's hard to select otherwise, and then I select those. So we like extend the boundary by 1 column and 1 row to check that they're all 1s there, and then we keep track of the maximum. So if we arrive at 3 here, then I memorize that 3 is the best so far, and then until I loop over all the indices possible, maybe I'll up it my 3 to something else, and then I'll return whatever number has been kept. But as we already said, this is not optimal, but it will do the job.
I think that even though this may be a brute force solution, it would be the right approach in checking the nearby values and having that inform how large the square could be.
Awesome. And I guess, do you want me to program this brute force solution, or am I going to penalize it? Should I just think about something better?
We can just move on to maybe what you would consider a more optimal solution.
Sure. Awesome. Okay. So these kinds of problems, I feel like I can solve them in 2 other different ways. The first one would be recursive. So here, the recursion can say, let's ignore the zeros, because as soon as I find a 0, we can just return from this point. You can't have a square. But let's say we get to this point, it's like, oh yes, there's a 1, so I can make a 1 by 1. Then we can ask the surroundings, can we make more than 1 by 1? And then if I can ask the square next to me, actually let me think about it. Okay, if this is a 1, the right of it is a 1, the bottom of it is a 1, we can ask this that I'm highlighting, how big of a square can you make it, actually?
No, I think you're on the right track, that you're checking the right, below, and diagonal values. But because there is a 0 here, does that mean it could be a valid square?
0 is invalid, right?
Yes, that would be the case. So based on that, what can you infer that if that you're at that 1 position at the that index, yeah.
If I'm at that index,
what can you infer is the maximum square?
At this index, it is a 1 because we can see the diagonal is already a 0.
Yes, that's correct. But you then know that the neighboring values are also 1s, so there is a possibility that those could have valid squares that are greater than 1.
Correct, yes. I mean, in this specific case, because the diagonal is 0, that means this next to this one below it is a 0. Unless we're coming from above.
True.
Right.
I guess the one below it, actually neither of those, but you could potentially have, as you're saying, a recursive algorithm. How would that look then?
Mm-hmm. So the recursive algorithm, I'm trying to think out loud as I'm describing the solution. So basically, when we see a 1 here, we can ask, can this be part of a bigger rectangle? And recursively, how would that look like? We have to ask the neighbors how many 1s they have consecutively, contiguously.
Mm-hmm.
So that could be saying that, okay, there's a 1 here, then we can invoke a recursive call that says how many 1s are starting at the right of me, making a square. So if I wish I can highlight, but let's imagine me, I'm gonna bold this, that marks the end and the beginning of a square. Yep. So when I'm at this one right here, I ask the square, I ask right of me, how big of a square can you be? And if let's say this whole area had 1s, even though it doesn't, if it had all 1s, the right of me should say, oh, I can do a 3 by 3. And I'm gonna try to break this down into maybe one step at a time. So when I ask this one, how many ones do you have, how big of a square can you form? It could ask the one right of it, how many can you form? It can ask the bottom of it, many can you form?
Yes.
And then whichever returns the minimum, I will take that and I'll add 1 to it. Trying to think if this will always be correct. So if this one said I can do a 2 by 2, let's say it claimed it can do a 2 by 2. I'm gonna change your input by a little bit if that's okay. So which means this would have been 1, this would have been a 1.
Okay.
The one that I'm highlighting is asking the one right of it, how big can you be, your square could be. This will say, oh, I can do a 2. Then it asks the bottom of it, how big of a square can you do? In this particular case, it's gonna say 3. Because I can see the ones like here, this one,
I think that
and this one are making a square.
I see. So you would compute it like top down. So that one that you've highlighted in 2-2 index or 2-2 coordinates would have it contain a 3 value because it can form that 3 by 3 square.
Right, exactly.
Got it. Yes, that makes sense.
And let me see if taking the minimum is sufficient, so to speak. So this one can create a 3 by 3, yes. The one right of it can create a 2 by 2. Or I guess now the example is so corrupted because I kept changing things. Let's see, actually, this one, yes. So this one, maybe I should color. So let me color this to red. The red one will say I can do a 2 by 2, starting from this coordinate.
Yes.
The blue one, or the one that will become blue, will say I can do a 3 by 3 starting at this coordinate.
Yep.
Now, how much can this one create, the one I'm highlighting? It would still be the minimum, I'm thinking, right? Because you can do more than 3 by 3. Okay, so now we can think about the base cases of the recursion, so to speak.
Yes.
So the base case, if we had a 0, then we return a 0.
Yes.
If we had a 1, then we ask the right and the bottom to do the recursion. We invoke them, and we return their minimum.
Yes.
I'm trying to think, in which case do we grow? I'm thinking we can grow, let me think. So if the red one hypothetically said I could do a 3 by 3, I'm just thinking, and the bottom one can say I can do a 3 by 3, okay. I need to think that there has to be that we can grow the ones, you know, we have to return a 5 or something eventually. So if the right of me can say I can do a 3 by 3, which, you know, so maybe I can hack the numbers, again, just for the sake of example. It can say I can do a 3 by 3, actually this is still a 2 by 2. Okay, I have to do this as a 1. So the red one can now do a 3 by 3. The blue one can also do
3 by 3.
Only 3 by 3, exactly. Then this one is so far is going to say 3 is the number.
Yes.
However, if this was a 1 right here,
It will be 4.
then it will be 4. But let me just like...
So that would mean the diagonal number would also be 3. To which case, because you have a 1 in that first field, at the 0, 1 coordinates, what could that say? If all of the 3 values down, diagonal, and to your right are all 3, and this is a 1, what could that be?
Makes sense. Okay, so if all the values are 3, then I should say I can do 4.
Exactly.
Makes sense. Okay. So I think I'm able to write it recursively. Of course, the recursion is not the most optimal because it has to retry something multiple times.
Yes.
We can always add a memorization memory element to it. This way, each unique invocation will only happen once, which will make this be at most quadratic. We will invoke it at most n squared times. But usually for anything that you can do with memorization, there ought to be a dynamic programming solution where you can do bottoms up. You want me to program the recursive memorization lazy version, or should I strive for the most efficient dynamic programming version?
I'm thinking that I want to first see your thinking for the bottom up, the dynamic programming solution, and then we can go ahead and code it. I just want to see what your thinking would be for how bottom up would look.
Sure, okay. You kind of gave me a hint already by saying check the diagonal if it also can do a 3 by 3. So in that regard, maybe this is the input we're highlighting right now. We can start with the dynamic programming array with this that has the same exact size, but it's initialized to 0 everywhere.
Yep.
Then at any moment that I want to compute an entry, I want to populate an entry in this DP matrix that starts with all zeros. I'll be looking at the same position of the input, and also the surrounding positions of the input, and potentially the surrounding positions of the dynamic programming array, the DP array, and populate it incrementally as such.
And so your DP array would contain what values exactly?
Okay, so at every entry in the input, if the entry in the input is 0, then we should write 0 in the dynamic programming array. If the entry is 1, then we need to basically look at the surrounding positions, as you said, like the top position, just top of me, just left of me, just diagonal left of me in the dynamic programming array, and we should take the minimum. But if they all agree to be like the same value, I'll just increment by 1 in the DP array. And the final return of this whole program is the maximum entry in the DP array.
Yeah.
Does that sound correct?
That sounds correct.
Awesome.
I do want to highlight that you will be then capturing the height of the square instead of the area in this array.
Mm-hmm.
And if that's fine too, if that's the direction you want to go in.
Capturing the height. Okay.
Because it is a square, so.
It is a square, I see.
Yeah.
That's right. Yes. Okay. Should I start programming the dynamic solution, and I can explain it as I program it, if that's okay?
That sounds great. Let's do it.
Okay, so programming Python into a document. So maybe I can choose Consoles as a font, and I can say def largest square, and it takes input as a binary array. I'm gonna say bin array. Is that fine? Do you want it to be typed or no typed? As in, like, you know, the typing of Python. Should I do something like this? mp.nd array, or at least say it's a list of int. Do you want these types?
It will be a list of, it will be a 2D array of ints. Yeah, that's perfect.
Okay, awesome. So, and then the answer is just an int, which is the maximum area.
Exactly.
Okay, so first I'm gonna say my DP array is equal to an array of all zeros. I guess I want to capture first n, which is just the length of the bin array. So it's could be a 5 by 5, 10 by 10 square, etc. That's n by n. So we want to make an all 0. I'm gonna do this. Okay, so now after this line, DP is just an n by n array with all zeros.
Oh, something that I wanted to point out here is that it's possible that it's a m by n. The width and the height do not.
May not agree.
Yes,
Okay,
for the input array.
Good to know.
But your output array or your output area should be a square.
Thank you for making this clarification. Okay, so then I will do this as my n times m.
Perfect.
And now I can say something like this.
Yep.
So let me just make sure, yes, I'm consistent in my indexing, so to speak. That if an index ij exists in DP, then it must also exist in bin array.
Yep.
Awesome, okay. So my DP starts at all 0. Now we're gonna do the double for loop that we mentioned. So for I in range n, for j in range m. And here at every square, we're gonna write the maximum that we can do.
Yes.
Scroll down. So let me think. First, if the entry has a 0, if bin array of I, j is 0, then in the DP we'll have a 0 in it.
Yeah.
So in that case, I will just, because the DP was initialized at 0, I can just continue. I can skip to the next iteration, if I'm allowed to use continue.
Yeah, of course.
Awesome. Okay. So then at any entry that's not a 0, we should look up the left and the top and the diagonal, and we'll see their values. So maybe I can say left value is equal to right value for now. I'll set them later. to the diagonal value all to 0, and I'll set them conditionally. Why? Because I don't want to skip the boundary conditions. So if the left of me, if I is greater than 0, that means I'm not at the boundary. That means the left could be something that's not 0. So now we set the left to dp of I minus 1 j. Yep. And I want to do the same thing, similar thing to the right one. Otherwise, they will stay at 0.
Quick question.
Yes.
Is it possible to handle the boundaries before you enter this scope?
Yes. Yes, I'm sure. So we could copy the boundaries from the input verbatim to the DP, and then our loop could be starting from 1 instead of from 0s.
I'm thinking more so that if you are in the 0th index of the row or the column, if there's a handling you could do before you enter this scope of setting the left and right diagonal indices.
So you're saying, like, before we enter these loops, we should handle the borders. Maybe that's what I'm hearing.
Maybe, yeah.
Yeah,
I think
so
it's possible to do it within the loop if you'd like.
we could.
Or let me know if that doesn't sound right.
We could do it. So you are saying that perhaps instead of having these if statements inside the for loop, I could do something before, then I no longer need these if statements.
You could do it outside of the for loop, you could do it within the for loop, either way.
I see. Okay. So yes, I can do that. I mean, there are many ways to do it. So I want to think that yes. Okay. So how about I wonder if it will complain. Okay. So mathematically speaking, I can do this left. Let me know what you think about this. So what if I set it to that and then I just multiply by a Boolean expression? I is greater than 0. So here, what I'm trying to do is to say the I greater than 0, this Boolean condition will only be valid, will only say 1 if I'm not at the boundary. If I'm at the boundary, then I can say your left is 0. Is that okay?
Yeah, that's possible.
That's possible.
But then what if the
then-
value is 1? Then the maximum square could still be 1, even in the row and column, like the edges.
Right. So yes, here, like this right and left and diag so far, they're just for reading. I still haven't inserted anything into the DP.
Okay.
My plan is to insert in a moment, like perhaps right now. Awesome.
Okay.
Okay. So if I is greater than 0 and j is greater than 0, and now I can read my diagonal. Diag is equal to. I'm gonna copy the line before and just add a -1, and now I want to write to the DP at this moment right here. So we just like we're brainstorming. If they're all set, then I'll read the minimum of the 3 and increment by 1. If they're not all set, then I'll just read the minimum.
Yes. And what would be the deciding factor for that? What would be the deciding factor of that?
So to increment by 1,
Yes.
basically the array right here, the array entry should have a non-zero.
Got it.
We're increment by 1, and that's the first if statement in the nested for loop. That if we are at 0, then we just skip that entry. We keep it in the DP as 0.
Okay.
So if the code flows until this point, then here I know that it's a non-zero point, and the top, the left, and the diagonal have some numbers, and using those numbers, the top, left, or right, some of them could be zeros. The top, left, diagonal, some of them could be zeros. If they are all set, that means I should take the minimum plus 1.
Okay. Yeah.
Makes sense, right?
That makes
Okay.
sense.
Awesome.
Yep.
If left is greater than 0, and right is greater than 0, and diag is greater than 0, then I will set the entry right here, dp I j, to the minimum of those. Left, right, I think I should put it in array syntax wise, I forgot, but I can try that. Plus 1. Okay. Let me think.
Quick question. Is there a reason why we need to check the that all the values are greater than 0 if we are taking the minimum here? If we've already checked that it's not a
You're right.
0 value, do we need to actually check that?
We don't need to. You are correct. Yes, so this if statement is irrelevant because if any of them is 0, then the minimum will also be a 0, and the final answer will be a 1, which is exactly what we need. You're right. This statement is not needed. If anything, it might make it work.
No, that's perfect.
Awesome. So we still don't have the final answer. The final answer is keeping track of what was the maximum. Of course, I can stay within the same computational complexity, and I can just say return the max over all of this.
Yep.
So return, I guess I'm gonna say row-wise max is equal to max row for row in dp, and then I can return the max of row-wise max. So row-wise max in this line, basically it becomes an n numbers. Each number is the maximum in that row, and then return the maximum of those. So we have we're invoking the max function once in this for loop and once again on the list, the fun list.
Is there a way to potentially get the maximum or track the maximum within your for loop?
Yes, there is a way. I can do that. Awesome, thank you. So I can start as the max, so max num as -1 in here, and every time I update, I basically read off the max. So I can say max num is equal to the max of the previous max num, comma dp I j, and then return that at the end. And of course, there is some, with every code, there is ways to optimize it. Like, for example, specifically here, we are storing in an index of an array. We're reading again the same index. I could have stored this as a variable z or temporary variable, but I'm hoping the compiler will take care of that for me. Will make it optimal.
Definitely. Yeah, this solution looks good to me.
Awesome. And I like the fact that you kept correcting me and gearing me towards the better solution. You are a good interviewer.
It was you. You were always on the right track.
Thank you.
I hope this gives you a better understanding of what it's like to answer technical interview questions at Google. As a reminder, be sure to explain your thoughts, get clarity when possible, think through how to improve your answers, and practice ahead of time. Thanks for watching, and good luck in your interview.
Okay, so we saw a mock interview, and I think it's quite difficult, but at the same time, I like this type of interviewing. I'm not sure I'm capable of this, to reply of this, but with a lot of study, with a lot of practice, it can be done, and it's perfect because our work is to think logically to a solution, and typically the interviews are like, okay, what is the difference between a list and an array, and sort of stuff that doesn't show how you think. Especially now that there is the ChatGPT, there is Copilot, and so on. The only quality that represents a good developer is thinking. So I like that Google is evaluating this stuff instead of only the knowledge, because you cannot know all, and maybe you can ask you can ask on Google, you can ask on forums, you can ask on IA when you have to do something. Instead, it's difficult that you can ask how to think. Okay. So I like it. And now we can see from a next Google interviewer some tricks about lead coding, okay?
This is Anthony D. Mays, everybody's favorite tech diversity hire, present for roll call, and ready for duty. Listen, I want to wrap with you real quick. If you're like me, you've had to do the infamous LeetCode style, riddle kind of coding interviews, and you probably are doing them wrong. Now, I've written an article about this, which I wrote in 2022, and since then, over 32,000 people have read it, 2,000 likes. It apparently really resonates. What I want to do is spend some time explaining some of the motivation behind why I wrote the article the way that I did, so that you can get insight into how to be successful in these coding interviews from the perspective of the interviewer. That'd be me. So, without further ado, we're going to spend a few moments just figuring out how to think about preparing for LeetCode style coding interviews at some of the top tech companies, so that you can be aware of the things that you should do and the things that you shouldn't do. Now, you know me, I like to tell you when you're doing it wrong. So why would I say that you're doing LeetCode incorrectly? I don't even know you.
Imagine being able to build an app with your name on it. Just
blah 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 blah. Okay, skip.
If you have been spending all your time trying to memorize LeetCode problems, if you have been spinning your wheels, just camping out at LeetCode hard, or if you've been rushing to just get to the first solution that you can and moving on, you're doing LeetCode wrong. Let's explain why that matters and how we can break that all down. First things first, I don't trust you. Turns out that a lot of people would do a lot of things for a $300,000, $400,000, $500,000 engineering job at a big tech company. So I don't trust you. You just need to know that. You need to understand that I don't trust anything that comes out of your mouth. Just giving you a LeetCode problem, you could have studied that, you could have memorized it, you could be using who knows what. That's why we don't use LeetCode. I know a lot of people expect that interviewers are going to just go to LeetCode and yeet a bunch of problems off there and give to you in an interview, but that's really not the case. I've got to know that you understand how to problem solve, and one way to do that is to give you a problem that you haven't seen before. So if you're spending your time trying to memorize everything on LeetCode, you're doing yourself a disservice, because most times it's not going to show up in your real interview. You might see problems that are similar, and that could be useful, but you can't count on already having previous knowledge about a problem that's going to help you to do well in the interview. So it really doesn't make sense to memorize problems. What you should be doing is what I tell everybody, which is don't memorize the problem, memorize the patterns, because the patterns are what's going to help you to solve a problem that you haven't seen before or that you don't have a lot of context on. So go learn the patterns, and that's going to put you in a much better situation for being successful. The patterns are useful for practicing how you use those patterns in the right context and in the right way. But don't spend all your time trying to memorize every single LeetCode problem, because you can do hundreds of problems and still be absolutely nowhere in terms of your own problem solving ability. Now look, some of y'all be crazy and y'all taking this AI stuff too far. Y'all gonna mess around and have to do interviews in person like we used to do back in the old days. We might get to a situation where people aren't even using computers anymore, right, for the interview process. I'm betting we're gonna be doing those whiteboard coding interviews again in the not too distant future. Y'all keep messing around and cheating, watch what happens. Second thing you need to know, I need way more than a right answer. I mean, can I pick your brain? What's up? I gotta know how you think. I gotta know how you communicate. I've gotta see what happens when you struggle. So if I give you an interview question and you already know the answer to it, that doesn't help me at all, because I haven't seen how you problem solve. I don't know how you're thinking about the problem. It's like doing a math problem but not showing your work. If I ask you a question and you already know the answer to it, all I'm gonna do is find another question that you aren't familiar with, or I'm gonna add another level to the question so that it increases the difficulty and just try to add some variability. The reality is that I need you to get stuck. That's just part of the process. And if you're afraid of getting stuck and you're trying to avoid it at all costs, you're not really ready to do the interview with me. Most people are not just brilliant with the ability to photographically memorize a bunch of stuff. And that's not what we need you to do. I need to see how you work through a problem from A to B and what you did to get between those 2 points, so that I can understand what it would be like to actually work with you, working on problems that you haven't seen before. One of the most important differences between you doing LeetCode and you doing an interview with me is that I'm not gonna give you the whole problem statement, all the examples, and all the hints up front. It's just not gonna happen. I need to know that you know how to ask for that information, which I have and I'm willing to give to you, but you have to be able to ask. I can't tell you how many times people have said, hey, are you going to paste the question in the window? And I'm like, no, I already said it. I will be more than happy to repeat it if you ask me, but now it's time off the clock. Don't assume that I'm going to do the work that you should be doing. And the work that you should be doing is asking questions, taking notes, memorizing things that I've told you, or at least documenting them so that you can reference that information later. I'm not here to do the work that you should be doing. Third thing you need to know, it is literally my job to help you. It's my job. I got to do that. I know. You see me as Darth Vader to your Luke Skywalker. I get it. But for real, I'm not here to beat you up. I actually want to see you succeed. I'm here to help you. So if you see me as the enemy and you don't ask questions and you don't talk to me, it's on you. Like, that ain't got nothing to do with me. I already got the job. You have to ask questions in order to get information that I have that I know that you need. I know there are people that say that there's no such thing as a dumb question. I firmly believe that there is a such thing as a dumb question in a 45-minute interview or an hour interview. A dumb question to me is a question that you've asked that you didn't have to ask if you were paying attention and listening to me as your interviewer. Now, many times it's possible for you to at least get some kind of answer even without asking questions, but your chance of like hitting the nail right on the head is gonna be super, super low. I usually know when people are gonna fail an interview because the first thing they do after they hear the problem is start typing out code. If that's you, you're doing it wrong. You're probably gonna fail before you've even gotten started. You end up spending time working on something for which you don't really have all the information to produce a really good, complete answer. You gotta realize I'm here to help you. Now, it does take some experience to know what kinds of questions you should ask, and this is where using tools like LeetCode or HackerRank really help you out, because as you work through a bunch of different problems, you can start to figure out the kinds of questions that you should be asking in order to get to an answer. This is also really important for studying algorithms and data structures in Big O. One of the reasons why we study algorithms, data structures in Big O is so that we can understand the kinds of questions that we should ask that will help us filter out solutions that might not work for our situation. For instance, if I know that the data that I'm working with is sorted because I've asked whether it's sorted or not, then I know that I probably don't need to use a sorting algorithm at this point. So I can just take those tools off the table because I'm not gonna need that. I've asked the interviewer if I need to sort the input, and they've told me that it's already sorted, so I'm good to go. So a lot of the questions that you ask are going to be about filtering out the list of all the different tools and things that you know so that you can get to the set of things that might actually work for you. If you can come up with multiple solutions, it is absolutely okay for you to ask me which one I would prefer. That is totally legit, and you should absolutely do that, because I might see that option B is better than option A, and I might push you in that direction so that you don't have to spend time implementing something that we both know isn't going to be ideal. You can totally ask that, and you definitely should, because that will save you time and help you perform better in the end. If you're not talking to me, if you're not asking me those kinds of questions, or if you're not brainstorming multiple solutions, I can't help you. If you can't figure out a better solution than your naive solution, by all means, go and implement it. But stop and think about multiple ways of solving the problem first, and then ask me to provide you some direction, and I'll be more than happy to point you to a more optimal path if that's the appropriate thing. Now, sometimes I'm gonna say just implement the naive solution. If you struggle on the naive solution, why would I have you spend time on the other one? I hope that you enjoyed this video. I hope that you learned something that you didn't know before. If you did, leave a comment. Tell me, how is your LeetCode prep going? How are you doing? Are you getting ready for interviews? Are you getting more interviews? Let me know. I wanna holler at you. Let's talk about it. Leave a like, drop a comment. Don't forget to subscribe. And hey, check the description. I've got links to articles and resources designed to help you level up in your interview prep. In the meantime, I'm Anthony D. Mays, Mr. From Compton to Google. Peace.
Okay, let's say I'll follow him. I'll follow him on fuck, on LinkedIn. Oh, I already follow him. I already follow him. What the heck? Okay. So. Okay, these are something to read. This is something to read. And I'll put it that way and put it that way. Now. Okay. Wow. It's very difficult. I repeat, it's something that I like. I will try to do lead codes implementing the questions to myself or to the samples. Maybe I'll try to implement with ChatGPT or something, let's say a mock interview with ChatGPT, and maybe I'll try to do something like that. But for now, let's stay focused on the lead code. Okay, and then we will try to do something more interesting. Okay. So I don't know if I'm doing this. Oh, these are like study. Whoa. But it's all premium. Okay. Okay, let's do a valid Sudoku. I like Sudoku, so let's do this. Okay. Determine if a 9 for 9 Sudoku board is valid. Only the filled shells need to be validated accordingly to the following rules. Each row must contain the digits 1, 9, each column 1, 9, each of the 9 3x3 sub-boxes of the grid must contain the digit 1, 9 without repetition. A Sudoku board partially filled could be valid but is not necessarily solvable. Only the filled shells need to be validated accordingly to the mentioned rules. Okay, this is hard. I think this will be hard. I think that this will be hard. Board DJ is a digit or a point? Okay, see, this should be the question I have to do. Like, okay, what is the board length and the board date? It's 9 and 9. What is the empty string? Is a point. If I don't ask it, I will don't know. If I don't know, I don't know how to manage the points. Okay. So we should check each row must contain. This is difficult for me. When we go through these lead codes, I understand that I need to study before something to do this. Really. Let's try to sync something, and then we can try to read the solution. Only filled shells need to be validated accordingly to the mentioned rules. Okay, let's put the sample 1. We have obviously E and J. or x, y, just to be more clear. X goes like that, y goes like that. I think that we should do something that is like, okay, let's check all the rows. Okay. Let's check all the columns. And then how we can check the 3 for 3? Maybe we can check it simultaneously. If we go like that, we can save tac tac. I think we can do a row and a column, and then we can go here. And we can row, column, we can go here, row, column. How do you move here? You should do 1 plus 1 plus 1. I'm in difficulty. I'm really in difficulty. Let's try to get an int. There are no ints. Okay, let's think. We should check the arrays. And say this array these are the rows and these are the columns. Okay, first of all, I have to check all the rows and all the columns. When I checked all the rows and all the columns, I know that it's okay. And then what I have to do is to divide the squares in a new list. Every list will be a 3×3 square. Okay. And then just check if in this 3×3 we have a duplicated number. I think with this we can do a good solution. But how I can divide the 3×3? I will construct the 3×3 while I'm going here. I think that I can just do like 1, 2, 3. Okay, first list. Then 4, 5, 6 is another. And 7, 8, 9 is another. Okay. So every 3 I'll create another list. Then this is epsilon talking is 1, 2, 3. So 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6. Okay, we can. I think I have it. Let's try to do something. Okay. I think we can. I think we can do something. It's difficult for me, but I'll try only with the 4 in F4. So. I will. 2, 3, close. 4, 5, 6, 7, 8, 9. I don't know. I'll do something really awful, and then we can try to do better. Okay, so okay, let's try to do something very, very awful, okay? No, I put something like I use a list just to if I use a set, an hash set, with an hash set I can know contains, and the triad, there is something like triad. Oh, okay, I can use the hash set with an add. Okay, so hash set of char, and I have empty. I'll do something really, really awful, I know. Just to second, third, 1, 2, 3, 4, 5, 6. Okay, let's do something more interesting, please. Okay, so I'll have the numbers from 1 to 9, and the hash set correspondingly. Okay, I can do something like that. I have the no, I cannot. Not okay. Okay. Let's see what happens. I'll reput some music, okay? Then we can do something like okay. You shouldn't be able to listen the music twice, okay? So this will be checked later, okay? Because I will yeah. Then for int y equals 0, of course. Y minor equals 9. Sorry, minor 9. We know that is a 9 for 9, so we can use this instead of board.length, okay? Just keep it simple, Andrea. Keep it simple, please. Okay. Yeah, I'm talking to myself. Therefore, int x equals 0. We are going to go x always more than 9. X. So we will go all the rows and then all the columns, okay? But we must do something like hash set char okay, column equals an empty, okay? Yes. And also a row because we need to check the column and the rows, okay? So here we will think about 5 and then 3 and then okay, so we can put okay, first of all we can do something like that. If try add if the column punto try add, this will return true if he can add, false if it already present. If it's already present, or if it's already present, we can break the cycle and return false, okay? So if column try add y, the board at the position y that is 0 and x that is 0, so we can say y, oh what the fuck am I y 0, okay? If this is false, return false, okay? Instead, if it's true, continue, and this continue. Same thing, we need to do also that here, of course, because maybe we can do here this return false, okay? If all this is okay, we checked the rows and the columns. With this we checked rows and columns, okay? We need to check the 3 for 3 because we can try to find out if this is already no, I want to do another case, okay? Putting an 8 like that here. This should return false, and this will return true in theory. But of course we have to finish, okay? We have to finish. There is an argument given to respond to value. What? Of collection, extension, triad, TK. Huh? I'm not handling the... Oh. Column is an asset. Oh. Ah. Okay. Okay. Why the second one is false? Oh, okay. Because it is an 8 here and 8 here. Okay. So, it's correct. We now checked correctly the columns and the rows. Okay. Okay. Okay, but we need to skip the empty part. So if it's digit, put it inside. We want only digits here. So if tac dot no, maybe string is digit, char is digit. Okay, we can do this. Should be like that, and then this. Okay. Okay, maybe now should be correct. But this should be true, not false. This should be true because let's do something different. Okay, this is okay. Because we want to check only empty stuff. Sorry, only valued stuff. Instead, this char is digit. We can do something like if char is not digit, continue, because we want to check only valuable stuff. Ok, if it's okay, we put the board yx, let's put cell, char cell equals to board yx. Okay. Okay. So we put it inside the correspondent dictionary hash set. Okay. How we put it inside it? For numbers 02, inside the first 0202. This is 022. This is y2 x3. So we can put like add into sub boxes dictionary. Okay, that is we should pass its y and cell. This is cell value. Okay, and we can do something like no, I'm overcomplicating this stuff. If y is minor than 2, we are in these three areas, and then so it's 1 2 3 3 4 5 and sorry 1 2 3 4 5 6 1 2 3 visit. Mm. 4 and 5 are not divisible for 3. 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5. Then 3, 4, 5, 0, 1, 2. Is the second? I don't know where is part. Okay. We can do like that. If y minus of 3, we can put if. I don't like it so much, but at the moment I cannot think something better. I don't like it. I really don't like it what I'm doing, but okay. Okay. This is really awful, but okay. It's okay. What the fuck I'm doing here? Really awful. I just use 1, 2, 3 to better comprehension. Then, wow, this is spaghetti code. Oh shit, holy shit. Divided by 3 plus 1 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 plus divided by 3 plus 1. So this is 4. 0 plus 1, it's 1. 1 plus 1, it's 2. And that's 3. If I go with 0, no, it's 4. It's 0. We have 1 plus 2. But this is the row, so okay, just leave it like that. Okay, this is really awful, but it's the only thing I can. I put. Okay, this is okay. Okay, this is this. I lost something, maybe. Why returning false? Why is returning false? This is something awful, I know, but what I have to do? Okay, but if okay, and then you have to add this box. Okay. At the moment I cannot think something better. Okay. I can't understand where you taking the false. If column add set value return false. Oh, because I'm adding at the column. What the fuck? Okay. Not set an instance of object. Solution is bari sudoku. where you broke yourself. What am I missing? Let's see what happens. Okay, sub box to check is null, and it's okay. It's null, so box to check is null. Okay. If is null or empty, we can simply add we can put like it's like this. Or just yeah, maybe like this. Maybe like this. No, we can do like that. We can do like that. What the fuck I'm doing? This is correct. If it's not null or empty, sub.to check instead is empty, and I try to add. Okay, so I need to do this every fucking where. I hate this thing. I really hate what I write. Hola. I assure that I am better than this. But I'm... Whoa. Oh, you're right. Alright. I think this is my... This is my worst code I ever written. The worst. How do I know if this is null or empty? Please. No. Contains, no. Case set comparer, blah 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 blah. Is okay, I don't know if it's null or not. Perfect. Okay, let's do in this other awful way. Okay. This should be correct. No. Wow, 500 test case. Ok. Biscottino for the solution. I biscottini sono finiti, però erano pochi, Erano pochi. Erano tipo una decina. Ok, expected false. Why should be false? Why should be false? 6. No. The one, two, three. Four. I need to understand where is the problem. Okay, so we have this. this, we have this. This, 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 and this. Okay. So this is the test case. Now, that's okay, and that's okay. Why should be, this, the column, I'm checking the column. If char is a digit, I try to add. If I don't add, return false. Instead you continue to check. Oh, yeah, but I'm only checking this column, only the first column. When I get with the x1, I'm checking the rows correctly. But no, I'm not checking the columns, really the columns, because when I change the y, I only check for the 0 on the x, and it's not correct, because I only check this. But the x is this. Okay. Maybe I try. Maybe I can do something like that. I'm not sure. I'm not sure. What? What the fuck you're saying? Char is digit. Skip. Instead, put it inside. But these are not columns. I don't have to. Allora. Think better. What I'm doing is I have a column and I have the row. 0 0, I'm here, and I put it in the column and in the row. 0 1, I will not put inside the column because it's another column, so I cannot put inside the column. This is a row. This is the column. I check the column doing I really have to do 2 times. Really, I have to do 2 times. I don't know. I don't know. Let's say in the first time I check all the rows. Okay. I have a row, and when I change my y, I pass to the second row. Now that's correct. The row. Now that's correct. Then when I want to check the columns, I have to do the reverse. So here will be the x, here will be the y, and here I have, yes. Now I'm checking really the column. Okay. This is quite better. This is quite better. What do you want? What is the problem? Okay. Now is really a Sudoku. Okay. Okay. I don't like so much what I did. Check row, check all. Okay, they did something similar. I think I did it quite better. Why this should be better than mine? Oh, come on, I want to analyze the complexity. Mine is a quadratic complexity, in theory. Because I have a 4 in a 4. Okay, let's see what happens. A valid dog board should satisfy 3 conditions. Each row, each column, each box has no duplicate. In example 1, from the problem description, board to 1 equals 9. We need to check the following condition. 2, 1. Sorry, 2, 1 equals 9 here. Does number 9 appear more than once in the third row, in the second column, in the first box? Can I do it smaller? How can I do it smaller? Maybe with 0, 1, 2, 0, 1, 2, 0, 1, 2, I'm here. So if this the difference, because that's it, it's 2, 5, and that's 3 the difference. Okay, so the difference is minor than 6. It doesn't make sense. It doesn't make sense. Compare entity to check for duplicates in each row and column given the row index and column index. We can create a hash set for each row. Oh, I did exactly what they said. For border C, we check if the number already exists in the hashes corresponding to the lowest row. Okay, is what I say. I did it here. I check the row in yx. Okay, if yes, this row. Yes. Maintains the duplicate value, therefore this dog is not valid. Otherwise we will proceed to check the next position. Okay. The tricky part is when we check the validity of each box. The question is, given row index and column index, how assign the position to one of the 9 boxes correctly? Each columns row 0, 1, 2 belong to the same box as do 3, 4, 5 and 7, 6, 8. Each columns rows 0, 1 and 2 as do. Oh, he's saying 3, 3 and 8. Okay. What they have in common? Every group of 3 belonging to the same box has the same outcome when we perform integer division by 3. Therefore, we can use R3 to ensure the rows are grouped as expected and use C3 to ensure the columns are grouped correctly. Okay, so 0, 0, 0, 0, 1, 2. Fuck. I was really close to this. So I should be able to do like this. I should be able to do like this. Oh, come on. I did it before, but I didn't trust myself. I didn't trust myself. But I can do this approach and then try to get value. Should be something like that. Oh, oops, I deleted something. I deleted something more. No, okay. Yep, sorry. You're right. It cannot be. Okay, 0 and quadratic, like I said before. The time complexity is 0 and quadratic. But the space complexity is 0n. Okay. Let's say okay, I don't know how to do that. I don't know. I need to study more. Okay, let's continue to read. Okay. But we understood. Reading from left to right, the box indices are continuous 0 from 8 and will increase by column first. It asks for each row, column and box. Okay, I did it correctly. Create an array of length 9 with values 0, 1 representing not seen and previously seen states respectively. Oh, okay, they put 3 different trees approaches. Oh, for the boxes are different. Asset to record the status. Boxes. So they put an asset of hash, no, an asset of char. I don't know. Oh, I did a better space complexity. I did this. Quite see. It's different, but okay. Okay. I didn't expect this good job. The only part I missed was this part here of the division by 3. Okay, I'm happy. I'm happy because I think that this would be an awful response, and instead is a good response. We can say there is quite good response. Okay. Okay. Sorry, just to 5 milliseconds and 28%. I'm just curious. Okay, it's the same. So why before it was better? I don't know. Maybe now he had to perform the division. Wow. If I do something like int subbox key equals to this, what if I do this, and you have to do it one time only. What change? Nothing is okay. I don't know why, but okay. You have to calculate only one time instead of two for every of this. But okay. It's okay. Okay, maybe it's faster to check the columns and the rows and then to do this. No, I don't think so, because you have to do 2 4 and 2 4, and in the second 4 you will check also the sub boxes. Okay. Let's go over with the longest consecutive sequence, the last LeetCode of the evening and the last LeetCode of the week with the raise and hashing. Okay. Let's try to know what happens. Given an unsorted array of integers, return the length of the longest consecutive element sequence. You must write an algorithm that runs in 0 and time. Oof. Okay. So we have integers that are not numbered, that are not sorted. We have to sort it, and then to see the longest consecutive elements sequence. So we have to sort it. For example, 100, 200, 1, 2, 3, 4. The longest consecutive element is 1, 2, 3, 4. So maybe at the interviewer I can say, okay, can I ask you for an example? Okay. Can I ask you for this example? 0, 1, 2, 3, 4, 5, 6, 7, 8. The output is 9. Okay. 0, 1, 2. The output is 3. Okay. So, first of all, we have to sort the array. Second, we have to cycle the array. And check if the numbers are n più 1, n plus 1 and sign it. Okay. I think it's quite simple. I don't know. So nums.sort, and then for each int n in nums longest sequence for now is 0. Okay, I should say what's the minimum sequence is 0. Okay, let's say that it's 0 because the why? Because the length can be 0. So if it's an empty array, it's 0. I mean, okay. So for each int n in n, if no, we go with this. For int e in e equals 0, nums dot count e più e plus plus. We say if okay, we have to check. Okay, so we have to start to 1, let's say. What if I have only one number? 0, 1, 2 is 3. The response is 1, I think. Okay, so if nums dot count equals 1, return 1. Equals 0, return 0. And now we can start from 1 and say okay, I start from 1 because I want to check the nums e minus 1, the previous one. the previous one plus 1 equals the current one. Okay, if that's correct, we put longest sequence plus plus. No. No. Current sequence. We have to take two numbers. Longest sequence and no. How I can okay. Current sequence equals 0. Okay. Current sequence plus plus. Okay. Then if else we are in the case that we interrupted the sequence. Okay, the sequence now is interrupted. We must check the if the current sequence if current sequence is okay, the longest sequence. Okay, so longest sequence equal current sequence, and then we must erase the current sequence. Okay, it should work. There is no sorting with the arrays, of course. I know that we shouldn't use sort type void. Oops. It's like cheating, but okay. Oops, sorry. Return longest sequence. It's like cheating. It's like cheating. 1, 2, 3, 4. 1. So we should start from 1. Okay. If there are numbers, is in self. Okay. Yes, of course. Output 1, expected 9. I'm not sure. Okay, numbers is correctly sequence is 9. Oh, okay. Of course, it cannot be an else. Okay. This must be done every time. Every time you need to check. Okay, we need to check. I don't like this else. I don't like this else. But I can do like that. I need to check. Before I do this, I need to check. Maybe with a while. maybe I can use a while. Using a while I can say like okay, e and e plus 1. Using a while, what changes? Nothing. Okay, I just put it here. I just put it before. Every time I restart, I check it. Should be okay. Every time I restart, it should be okay. It's 9 because the last number I didn't check it yet. I didn't check it the last time. Instead, if we do like the next one, this approach should be okay, because if the next one I will check inside the if, and the last number is not a problem for me because I already checked it. So we start from 0, numbers count -1, and I check my numbers +1 must be like the e plus 1, and this would go here inside here. This makes sense. This should be okay. 1 0 1 2, expected 3, output true. I must sort it. Oh shit. I don't have to sort it. I just have to check If there are or no. Holy fucking shit. Ok. I don't want a list. I want a set. If I do an hash set, should be fine. But I don't know if this is, I'm sure that the hash set doesn't have the sorting type. I don't think they have the sorting. Exactly. Okay, maybe I can do like to hash set. Maybe let's start to an hash set because I don't give a fuck of the duplications. Okay, and then this is not allowed, of course, but then I can, from an hash set, number set, I can do a list from the hash set, and then I can sort the list and this will work. I don't know if it's okay. I'm wasting a lot of memory. Yeah, it's really bad. Oh, and log n. It's a good one, I think. Is this a good one? No. Oh, and log n is not good. Okay, let's see what they did. An hash set, okay. And then they cycled the asset, and okay, of course you must check the contains. You don't have to sort. Yes, of course. Let's try to implement. I have an asset. I give a fuck. Okay. I have an asset, numbers. And okay, I try to do something better. Okay. Nums. If the count is 0, I return immediately. Instead, numbers. Okay. If numbers, I know what is it. The what I want to cycle. I want to cycle the nums. Okay. I want to cycle nums. Why? This is smaller, so I want to cycle the smaller one. Okay. Okay. Int current numbers equals to numbers e. Okay. Okay. If numbers contains current number plus 1, I will update the current sequence. If the current sequence is bigger, okay. Else, if doesn't contains okay. Okay, should work. Cannot apply indexing with. Oh, okay. How can I? Oh no. I stupid. For each int in int n in numbers, I don't even need this before, and n plus 1. Okay. Cannot be applied to type method group and int. Only you. Okay. Why? Because in this case I start from 3 and it's not a good idea. Of course, because if I start from 3 I will get 4, 5, 6, 7, 8. But if I start from the maximum and then I go back, or if I start from the minimum and then I go back and I go up, if I start from the minimum, I go up to 1, then to 2, then to 3, then to 4, then to 5. Let's wait. Okay, instead of this I do a while numbers contain the minimum plus 1. Yeah, maybe I can do like that. While numbers punto contains min plus 1 and int min equals numbers. How can I know min or set? That is min. I don't think so. Okay, I'm not sure. Let's do like that, but I'm not sure this it work. Let's see. Okay, seems like this is okay. So this work. Okay. So while the minimum is while the asset contains the minimum plus 1, okay, I will current sequence plus plus. If current sequence more, okay. But if it doesn't, how can I re-enter in the while? That's a problem. Maybe I can do like that. will delete the min, and I will get the new min. What do you think? Maybe this is better? No. Forse remove, not delete. Maybe it's remove. Add, remove. Sequence contain no elements. Because I removed all. Okay. If numbers punto count maggiore di 0, like that. Okay, maybe this is better than my previous one. I don't know. No. Why? The complexity is better. But the complexity is better, so why? I'm not sorting nothing. I'm just checking for the contains. Maybe if number contains min plus 1, blam, bam. I can do like that. If number contains min plus 1. Okay. Else current sequence equal 1. And I can put like that. I can put like that. Here I can put like, okay. The new min is min più. Maybe this is better. I don't know. No. I can't understand. Okay, I give myself 5 minutes, then we can go off. Okay. We did it. I'm only trying to. As you can see, we did it 15 minutes ago, but I didn't like it so much. So I'm trying to have a better approach. This was better because once we sorted all, we check only the next one. We check it only in the next one. Now instead we are always getting the minimum number, and remove it, and so on. So maybe without removing and saying okay, just take just get the number that is bigger than the last min without removing it, maybe. Okay, go to see for each bar and in offset count to equals 1 and plus 1. This wasn't okay. Oh no, I want to see. I don't know, I don't like it, these approaches. They're using a for each with a while. Why they should be faster than mine? No, it's not interesting because how can I know what is the next of a min? I cannot know. without sorting, I cannot know. Okay, let's see what says the solution. We can exhaust the entire search space by building as long a sequence as possible from a number. The brute force algorithm does not do anything clever, it just considers each number in nums, attempting to count as high as possible from the number, only in number. After it counts to I, it records the length. Okay. And I prefer the solution I gave before instead of this. O3 o uno space complessi. Sorting. If we can iterate over the number in a chain, then will be easy to find. Before we do anything, we check for the base case input of an empty array. The longest sequence in an empty array is of course 0, so we can simply return 0. For other case, we sort the numbers and consider each number after the first, because we need to compare each number to its previous. It's what I did it before. If the current number and the previous are equal, then our current sequence is neither extended nor broken. Suppose that the last elements of none is part of the longest sequence, so we return the maximum of the current sequence and the longest one. Here an example array sorted before the linear scan identifies our constituency. The longest sequence is colored or red. O(n) log n O(n). Asset and intelligent sequence building. Okay. This is what I'm missing. It turns out our initial brute force solution was on the right track, but missing a few optimizations necessary to reach O(n) time complexity. This optimized algorithm contains only two changes from the brute force approach. The numbers are stored in an hash set to allow 0-1 lookups, and we only attempt to build sequence from numbers that are not already part of a longer sequence. This is accomplished by first ensuring that the number that would immediately precede the current number in a sequence is not present. So, if not contains the previous one, check. The complexity is 0n. Although the time complexity appears to be quadratic due to the while loop nest. Oh, it's a false quadratic. Closer inspection needs to be linear, because the while loop is reached only when current num marks the beginning of a sequence. Okay. Okay. Just to remember myself, I want to put inside. Okay. Okay. I didn't think about this solution because I think it was a quadratic one. Instead, it's a linear one because we start the while cycle only when we took the minimum. Of a sequence. Okay, I'm not sure. Okay. 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 Okay, I think for today we are okay. 9 problems solved, 3 easy and 6 medium, and we finally reached the completion. We completed array and hashing. So we will start with stack and 2 pointers. Before we do stacks, and then we go with the 2 pointers, and then we will go with the sliding window, binary search, and linked list. I think that I should study some theory instead of doing only the LeetCode. So maybe, okay, we saw the array and hashing. Okay, before starting to do the LeetCode, I should study all these things. Yeah. Okay, thank you to be here today and this evening. I don't know if we will see. I don't know if we will be live tomorrow and on Sunday. I'm not sure. In case you will find myself on YouTube and Twitch live. In case I'll be offline, I'll try to study. And more important, I'll do my pizza. I'll eat pizza on Sunday. Okay, thank you to be here. Good night. Have a good night.